road trip to Vegas. reInvent 2021. How has it been 10 years?
Please welcome Chief Technology Officer of Amazon.com, Dr. Werner Vogels.
Nope. Now, that's what I call a ride. But first, music. Shall we? What is that? Lambda.
It's AWS Lambda, which is an event-driven compute service for dynamic applications. And you have to run no servers, no instances. Server-free backend.
Wait, we can't stop here. It's bad country. It was only last year.
It's never been a better time to use your knowledge, skills, and talents to make a difference in the world.
I know the way. Yes, I will find you.
Can you believe it? 10 years. 10 years of reInvent.
I know the way.
From 2012 to 2021, a celebration of innovation on behalf of our customers. I'm ready, Las Vegas. Are you?
Please welcome the Chief Technology Officer of Amazon.com, Dr. Werner Vogels.
So, welcome Las Vegas. How are you doing this morning? Hey. Did you like my choice of music today? Can we get an applause for the Cactus Quartet out there? They were absolutely amazing. And this may be year 10 of reInvent. That doesn't mean I'm not going to wear a t-shirt, though. Yeah? So let's make sure. I've realized that many of you have little insight into the 80s punk and new wave era. So, in that case, for the few of you from the UK that actually know this band that had 19 albums on the charts, the Stranglers. Okay, 10 years. 2012, when I did the first keynote at reInvent, still is very much alive in my head because I thought that was such an amazing first reInvent at all. And we'd never done anything like that before. And the cloud was 5 years old at that time. We had quite a bit of experience already with that, but we were giving you lots of advice that actually has come back over the years. And again, I think what you will see today is actually I will be reusing some of these advice that I gave you in the first keynote because they're still valid today. And if I look back, sort of thinking about sort of how did this all get started, and I'll take you a little bit on a memory ride and see how things have evolved over time. And I think things started off, of course, with that innovation was constrained. Because before cloud, you either had to get massive investment, you had to buy hardware, you had to hire IT people, things that had nothing to do with actually building a product. And the one thing that cloud really did in those days was go from everything that was constrained, all the hardware pieces, to making them all programmable. Suddenly, getting access to capacity was just a click of a button. And whether that was networks, it became VPC, or AZs as data centers, ELB for load balancers, RDS, S3, EC2, all of those were physical resources before, but now became virtually programmable. And that made all the difference, because it wasn't only that you could scale up by buying more hardware, you could actually scale down easily as well with a click of a button. And that made all the difference. So if we look at the EC2 in those days, they're really simple. One single family with 3 different sizes. And the interface was simple. Create, launch, terminate. And the kind of things that you've done over the years with EC2 instances has become, let's say, very ambitious. And every day, almost, you asked us for a different instance family. You wanted storage optimized ones. You want compute optimized. You wanted to have large memory instances where you could run your SAP HANA in. And so where the first instances were all based on a Linux hypervisor, we needed to do massive investments and innovations in our data centers to make sure that we could get sort of next generation compute platforms into your hands as well. And Nitro, where I talked about 2 years ago, we went in depth exactly how we were using Nitro, the Nitro hypervisor, made it possible to introduce all these new hardware platforms for you. And especially our shift to ARM has had significant impact on cost and performance for everyone. But to be honest, the most popular launch in the last re:Invent was actually a Mac. And so, but the one thing that Apple has done is followed the same path that we've done at AWS. And they also went to their own silicon and built their own ARM chips. So today, I'm happy to announce that you will get your hands on the Mac EC2 M1 instances. So that you... Yeah, let's make that the most popular launch this year as well. Yeah? And so, so it is actually, just like with the Graviton processors, price performance is significant in ARM. And I think Apple claims for the M1 Mac instances that there is a 60% cost benefit improvement over, let's say, the Intel platforms that they used before. Now, all these different instance types makes that you guys are doing a lot of work, really a lot of work. And that results in 60 million launches of EC2 each day. And this is doubling the number of launches that we saw in 2019. You can't do this on bare metal. And remember, these are launches a day. That's not even the steady state running EC2 instances that are out there. This is quite impressive. Don't you think so? 60 million instances a day. Now, as I said earlier, the cloud removed those constraints. However, it didn't remove all constraints. And if you go back to the 2012 presentation I gave you about the new world and removing constraints, I promised you I would fix the speed of light. It's still on my to-do list, though. Yeah? So there are a number of what I would call laws that sort of continuously are the constraints that we have to deal with. Yeah, whether there is latency and bandwidth, or the robustness of your network connections, or the law of the land, data residency. Now, that one is actually one of the, I'd say, easier ones, but it's one of the things where we're making most progress. Yeah? Working together with regulatory agencies around the world to educate them about cloud and what the capabilities are, and that the security and the protection that they get with data in the cloud is much better than that they would ever be able to get in their own data centers. Now go back to 2006. If you think about removing these constraints or dealing with these constraints, in 2006 we only had North Virginia. Yeah, that was the first region we launched. And you can imagine that if your customers in Japan or in India or in South Africa, latency towards Virginia was significant. So launching these other regions, the first regions was in Ireland in 2007, and we launched Singapore and North California. And if you look at that, customers now could start deciding which region to use based on where their customers were. And for example, a company in India, Hungama, a media streaming company, would be streaming their content out of Singapore, but would actually be using North California for doing transcoding. Because remember, these regions are all cost following. So suddenly they could make choices for things that weren't actually latency critical, but lower cost, versus maybe a bit higher cost, but lower latency. And there's applications that we could not have been building if we didn't have, let's say, these regions closer to you. Now, take, for example, Alexa. I think in 2006 or 2009 or even 2013, Alexa would not have been possible. And why not? Because you need ultra-low latency to make sure that you can reach the Alexa voice service, which sits in the cloud. And if you don't get a response back from Alexa within a second, it doesn't feel like a natural conversation. And as such, both the advances in hardware, in GPUs and machine learning, and both in hardware and software, have enabled the capabilities of Alexa, but we still needed to drive the latency down such that the network would not be in your way. Now, to that, we developed this global footprint. Today, we have 25 regions, 81 availability zones across 6 continents. And I'll promise you, by the time we finish this keynote, you will know that it is actually in 7 continents. And so we're continuously working to expand this. There are 9 more regions planned that we will bring online in the coming 2 years. And each of them will continue to help you reduce your latency, but also address data residency requirements. Now, if you think about latency, it's not only the regions that become important to you. Yeah, we have 310 points of presence around the world. And we use these POP locations to deliver content at high speed through CloudFront. But not only is it a content distribution network with Lambda functions, CloudFront functions and Lambda at the edge, you're actually also able to do computation at the edge. And if you make use of S3 transfer acceleration, you make use of each of these endpoints to really, at high speed, move data into S3, beating sort of the bandwidth limitations that you otherwise would have. Now, it's not only that way that we bring you closer to the AWS capabilities. Now, in the past 2 years, we've been building local zones, which you get your services even closer. We currently have 14 local zones. And we started off in the US to actually start to understand how to best build these zones and how to best use them and how our customers will be using them. And there's a subset of capabilities running in a local zone that is attached to a region. So there's EC2 and EBS and ECS that you can run there. And basically, you can build a VPC in the region, extend that VPC into a local zone, and actually move your containers back and forth seamlessly within the same VPC. Now, I'm happy to excite, and I'm very excited actually, to announce that we will be expanding the local zones internationally across the world. Yeah, there's about 30, at least 30 new AWS local zones coming online in Europe, in South America, in Africa, in Asia, and in Australia. And of course, we'll have one in my home city of Amsterdam. Now, one of the very interesting applications I've seen that make use of local zone is a company called Jacktrip. and they do sort of remote live performances of music. Now, to be able to do that, the maximum time for synchronization is about 25 milliseconds. So imagine there's a group of musicians spread out through Austin. After all, you know, the live musical capital of the world. If they would have to connect to one of the regions, let's say in Virginia or Oregon, latency would be too high. It would be impossible for them to play synchronized music. So they connect to the local zone in Houston, which makes it possible for them to completely rehearse and actually do performances live over the internet remotely. And given the situation that we've been in for the past 2 years, this was really important for them. Now, that's not the only way we started trying to overcome the limitations of speed of light. Yeah, and AWS Wavelength is a good example for that, where actually sort of the low latency promised by 5G, we do not need to add more latency to that for you to go to a region or to a local zone. So that's why we put actually AWS capabilities inside the 5G access points. Again, trying to overcome sort of the restrictions that the speed of light and latency give us. And quite a few of our customers are running things like machine learning inference in those instances, or game streaming. And this already starts to get close to the network. So let's take a look at what we've done in the physical infrastructure, but now on the networking side. Let's go back to 2006 again. When we launched North Virginia, the world was pretty flat. Basically, you launched an instance, we assigned an IP address to it, and the network was just flat. And if you wanted to go talk to other instances, you needed to go over the public internet. And so the early enhancements to EC2 really focused on the networking. How to do autoscaling, how to do load balancing, how to get insights into your network with CloudWatch. And one of the first things we did also was actually introduce elastic IP addresses, meaning that you could actually have persistent IP addresses instead of one assigned at boot time to you. Now, the most important launch, I think, in the networking space has been VPC. And we launched that in 2009. This allowed you to cordon off a piece of the cloud, assign your own addressing blocks to it, then connect it back to your own data centers, so it seemed like your data centers were seamlessly expanding. You could use VPN for that, or later Direct Connect. And this was still, in the early days, a pretty flat network. However, in 2013, we started making VPC the default. And EC2 Classic, which we recently started deprecating, is now sort of the old-style network where VPC by default really is the one that you're using. And if you look at sort of how the AWS backbone has evolved over time, that looks very different from how we look like in, let's say, the late 2000s. And the backbone of today consists of a fully redundant 100 gig network. And it's not just our control plane. You can use our backbone. Where in the past, if you would communicate between two VPCs, you would go over the internet. Now you just transfer over the AWS backbone. And this is really one of the most highly scaled, purpose-built global networks ever assembled. And it's growing really, really fast. And if you look at sort of the core networking products that we built on top of that, there's a whole variety of them. And I mentioned earlier S3 transfer acceleration that basically makes use of this backbone to get your data to S3 as fast as possible. Now, even with all of these components, building a global network connecting maybe hundreds of your offices to the cloud is still a big challenge. And it will be the first time that I actually meet a customer that shows me a massive spreadsheet which he uses to manage all the connections between manufacturing sites and back offices into the cloud. So there's a lot of work going on there. And actually, quite a few of these customers are literally running thousands of VPCs, if not tens of thousands of VPCs. And so we started to think, how can we help these customers sort of really overcome all the heavy lifting that you have to do if you have a very widespread network yourself that you need to connect to the cloud. So today, I'm happy to announce AWS Cloud WAN, which gives you the ability to build, manage, monitor global private wide area networks using AWS. So how does this work? Yeah, imagine you are a very large global company and you have dozens of manufacturing sites around the world. You maybe have offices in each of the big cities around the world, and you need to connect them all to AWS because that's where your applications are running. Now, the first thing you do is you start selecting the regions you would like to use. And then, automatically, once you actually define this, all your remote users and site and data centers will connect to the geographically closest location using a VPN or direct connect. And this is actually built for you in minutes using the big AWS backbone for you. We basically give you a highly reliable and highly available software-defined wide area network running over the AWS infrastructure. And it's not just that. You can actually also segment these pieces of software-defined network that you've created. Maybe you create a separate segment for your corporate office, you create a different segment for your manufacturing office, for your manufacturing sites, and these segments cannot communicate with each other unless you explicitly allow it. Of course, we'll give you a dashboard for which you can monitor all your network activity. And it gives you visibility in availability, you can troubleshoot connectivity and performance issue, and so on. Actually, this would not be possible without this wide range of partners that we've been working with, and whether that is in the telco business, system integrators, and these software-defined wide area network vendors that actually help us with their technology to build software-defined WANs privately for you over the AWS backbone. Now, think about regions, what we talked about. Well, there's much more than regions. Yeah, we already said that to overcome sort of latency challenges, we give you points of presence, we give you these wavelength zones, we'll give you local zones. But, cloud has gone much further. And you've asked us for so much more than just these zones and these points of presence. One thing, of course, was another way to overcome latency requirements is by actually moving AWS closer to your data centers. And we've done that, of course, with Outpost. Yeah, and over the years, we really heard that you have certain workloads that you cannot move out of your data center. It might be that your SAP system is connected to a database that for some reason you're not willing to move. However, you want to build all your new applications or even older applications running on AWS. So the prime reason for Outpost is to actually beat the latency between the AWS cloud and capabilities that you're running in your own data centers. Yeah, so by moving either the 42 racks into your data centers, you can have extremely close connectivity. Now, if you look at customers that have been very successful with Outpost, it's all for a variety of reasons. FanDuel does it to beat latency and actually reduce their latency for their gambling between themselves and their customers. First Abu Dhabi Bank in the UAE makes use of Outpost to actually meet data residency requirements. And they actually make use of multiple outposts in different locations in the UAE so they can do business continuity using Outpost. And Philips does this for, again, for local processing as well as for data residency requirements around healthcare. Now, we started off, of course, with a 42 rack. But now, actually, we also give you these two other Outpost instances, is that, for example, in retail locations or your edge offices, you can bring AWS into those offices. But there's a reduced set of capabilities running, of course, on Outpost. And again, it connects back to a region from which you can monitor and manage all the Outpost capabilities that you have. It does have all the important ones, RDS, EC2, ECS, and the services run directly in your data center. Now, so those are your data centers and your offices. But what about these other billions of devices out there that are connected now? Yeah? So how can you actually connect all these devices to the cloud? How can we help connect those? And I actually call this the Internet of billions of things. Yeah? And for that, we give you FreeRTOS as a stable base, as an operating system for these devices. We give you AWS IoT Core to manage all of those devices and to create digital twins and shadows and things like that. Or if you have a need to run the IoT capabilities on your devices itself, we give you Greengrass. Now, for Greengrass, I've seen a number of very interesting applications. One of them is in the autonomous trucking in hazardous mining conditions. So these trucks will be autonomous, they'll go into a mine, and actually on that truck will run Greengrass. Completely autonomous, collecting data, managing the device, and actually storing data at the gateway, which once connectivity is restored, it will upload it to the cloud and you manage it there. So that's really the Internet of billions of things. But those are the billions of things that were actually already connected or could be connected to the Internet. There's also many devices, definitely in manufacturing environments, that are not connected. They're old. The typical age of manufacturing equipment in the US is 27 years. That means that these devices were not modern data generators at all. So for that, we give you Monitron, which is a physical appliance with a bunch of sensors that actually manage these data coming off the observations of devices. They do vibration and temperature and things like that, record all of that, move it through a gateway, move it into the cloud, and you can manage it there, for example, for preventive maintenance and things like that. There's also something very special around one particular data stream, and that is video. Now, for many of us, we still watch video to be watched. But in essence, video is nothing else than a data stream to be analyzed. And so many manufacturing sites, but also retailers, have many cameras around on site. And you can actually make use of those data streams to analyze them. Now, the Panorama appliance, you can actually move custom machine learning models onto it, run inference there of the data streams coming off IPTV cameras. And so, for example, I've often been asked by retailers, how can we understand how people are moving through our store? How much time they're spending in front of this promotion, or the impact of changing the layout of my store. And I've always told them, you already have that data. Yeah, you have 30 security cameras in your store. But you have someone watching those streams to look for fraud or for theft or things like that. But in essence, they're data streams that you can use to analyze exactly how people are moving through your store and how much time they spend where and how. And for example, the airport of Cincinnati is making use of the Panorama appliance to understand how people are moving through the airport. And so that's all because video has become a data stream to be analyzed instead of something to be watched. Now, if I think about sort of environments that are even further out, outside of manufacturing or retail, yeah, there's all sorts of requirements that suddenly come there as well. Most of them need to be compliant, especially, for example, in medical environments, or they need to be rugged, because we use them in environments in deserts and things like that. Or, you know, they really need to be able to be remote. And this is where I promised this 7th continent, because a bunch of these devices have been taken to Antarctica, and I'm happy to announce that, you know, the 7th continent has now also versions of the AWS Cloud on them. Now, the rugged edge is what we call this. Yeah, and you have seen most of these devices over the years. Yeah, and whether you have snow cones, which are small and very mobile, whether you have snowballs that are still, let's say, transportable, but they're a bit bigger and heavier. But there's the storage optimized version of it and a compute optimized version. And then, of course, the snowmobile. If you have so much data, petabytes of data sitting in your data center, that you need to move to AWS, snowmobile is the way to go. Now, this is sort of the current state of the world, of the cloud world. But, can we go even further? What is the next frontier that we really should be able to address when you think about cloud computing? And of course, we think about space, we think about deep sea, we think about sort of Antarctica, but also start off with space. Now, AWS Ground Station, again, was one of these approaches to virtualize something that was ridiculously expensive if you would have to build it yourself. And so again, by making ground stations programmable, we suddenly are enabling a lot more innovation in the space. And so again, you have ground station, data comes off the ground station, you basically just rent a 10 at a time, you get your data off your satellites and move it into AWS. And one example of that is the Mohammed bin Rashid Space Center in the UAE launched the HOPE probe in early 2020, and in 2021 it arrived at Mars. It is now circling around Mars, doing research around the Mars atmosphere. That data, through ground stations, being moved into AWS, pre-processed, and then within 20 minutes made available to the global research community. Now, to actually tell you more about space and innovation in space, I'd like to welcome Payam Banazadeh, the founder and CEO of Capella Space. Thank you.
Thank you, Werner. Imagine if no change in our world went unnoticed and unmeasured. Imagine if we could build a digital clone of our physical world that was getting refreshed in real time. Imagine if we could have seamless and automated interactions between our physical and our digital world, such that you could set a trigger that involved not just events in the digital world, but it could also be triggered and acted out in the physical world. Let me give you an example. Imagine you could monitor all the ports and all the shipping lanes in the world all the time in real time, and you could set the following logic that was working for you in the background. If there are more ships than container capacity, then increase trucking support. If that's not possible, move some of the ships in this shipping lane to this other shipping lane, to this other port, optimize for ETA. You'll be able to catch issues and potentially prevent supply chain disruptions from happening in the future. In 2019, on this same stage, a company called Saildrone told you about deploying sensors in the ocean to collect valuable measurements in real time. There's also been a significant growth in quantity and quality of terrestrial sensors in the last few years. However, the next frontier that is now becoming accessible is space. And sensors from space have a truly unique vantage point. They are needed for us to have a connected world. In fact, to make truly global decisions based on global information, you need global access all the time. For this, space is the missing link. Over the last 6 years, we've been designing and building some of the most sophisticated satellites on our planet. We can track changes on the surface of our planet to millimeter accuracy. These are powerful satellites. And these satellites have some magical capabilities. We can take images through the storm at night in all conditions. It gives us reliability, and it gives us visibility into our planet in all conditions. That's a fundamental requirement for getting to real-time monitoring. In fact, this picture of George Washington Bridge was taken 3 in the morning on a stormy night from space. We have 5 of these satellites orbiting Earth right now, and we're launching more and more and more of them in the coming quarters. As we launch and scale our constellation, we're going to be accumulating a lot of data. In fact, over the coming years, we're going to have more than 500 petabytes of data getting accumulated coming down from space from our satellites. That's a lot of data. Handling that much data at scale is a challenge on its own. But it's an even greater challenge when you combine our data with data from other space sensors, other terrestrial sensors, and other ocean sensors. In order to lay the groundwork for integrating our sensors with other sensors in real time with low latency and low reactivity, we had to build our business on a completely different foundation than traditionally has been tried before. We had to think about so many things. We had to think about a distributed network, no human-in-the-loop operations with full automation, real-time processing of data, unlimited storage and processing power, and instant scalability. This is why we work with AWS to enable this future. We needed a company that could support us with resiliency, could scale with our constellation and demands, could support our automation, and by the way, do all of this in real time. So 500 petabytes of data, no problem scaling that out on S3. A flurry of new hurricane images coming down, casual with just auto-scaling infrastructure on EC2. And if we need that hurricane image even faster, that's pretty simple. We'll just grab the next pass at the AWS ground station. And the AWS ground stations are integrated into the AWS fabric. They're also in close proximity to the data centers, which means the data from our satellite to the ground station through the secure VPC, getting into the cloud happens within milliseconds. And with our entire system on AWS and our platform built on a robust API, ordering imagery from space is like ordering food from your favorite food delivery app. Fully automated and with no human interactions. Let's just take a look at how easy it is to request an image from one of our satellites. You pick a location of interest. Let's pick Las Vegas, and literally 3 clicks into it, you've tasked the satellite. We take care of the rest. The satellite goes over the areas of interest, collects imagery, comes over the ground station, dumps the data down, the data goes to the cloud, gets processed, and boom, you've got the data for your consumption. And here's the best news about it. This is all on an open API, which means you are one API call away from accessing a global network of extremely powerful satellite sensors. That means if you want to automate your end of this process, you can use our open API and just blend us into your workflow. Let me just emphasize that. You are literally, right now, while sitting in this room, one API call away from a global network of powerful satellites. This is game changer. Machine-to-machine operations and full automation are together the fundamental catalyst for taking action in the digital and in the physical world. So let me just tell you a few stories from this year where machine operations led to humans taking better decisions. Oil spills were detected using our imagery automatically. Chinese dam failure was verified using our imagery automatically. Volcanic researchers identified new vents by peering through the smoke of an ongoing eruption automatically. Local agencies were informed of deforestation in Amazonia automatically. And of course, during Hurricane Ida, our satellites were monitoring the daily progression of the hurricane and flooding through the clouds and storm day and night, and pushing out updates in real time to our customers automatically, and many, many, many more. I'm sure you can tell we're really, really excited about this capability. When I took the stage 6-7 minutes ago, I open by showing a conditional flowchart of setting triggers and connecting our physical to our digital world. Thanks to companies like AWS and Capella, that future is a reality today. So before I leave, I ask you all this: what would you do and what would you build if you were one API call away from seeing our planet and its billions of changes? Thank you very much.
Thank you, Vanya. There's so much interesting innovation going on in space. It absolutely is the next frontier. And as always, in AWS, we've been very closely connected to the startup world. And so recently, we launched the robotics startup accelerator. We launched an early start accelerator for startups in Europe. And of course, we also recently ran our Space Accelerator, which had 10 different companies that are making use of the AWS Cloud and are going into space. And one of those is very interesting. It's called Deorbit. And they're actually working on sort of supply chain logistics in space. But they're also working together with an AWS partner called Unilab, who actually brings the cloud into space. So if in the future you're looking for, let's say, a Lunar 1 region, we may not be that far away from that. So if you think about sort of, I hope so. So if you think about all these different components of the cloud, and there's a spectrum of hardware and devices and services that expands the reach of the cloud way beyond regions and availability zones. I have nicknamed this the everywhere cloud. And customers will always want to manage their applications centrally, even though they're distributed. But you can push it out all the way over to the edge, and where you can see all AWS services running transparently, regardless whether you're running it on the rugged edge, whether you want to run it close to your space satellites, or whether you want to run it in your own data centers. And it's not just the hardware. From day one, we've been thinking about all of our software capabilities that sort of needs to span all of these different components that make up the everywhere cloud. And one of the earliest ones, is still one of my favorites there, AWS Storage Gateway actually brings the power of cloud storage directly into your own data centers. But one of the things that I really want you to walk away with is that, yes, this is a massively distributed system. But it's not decentralized. It's distributed, but not decentralized. And I would like to sort of spend some time on one of these services that touches each and every component of the everywhere cloud. And that is identity and access management. AWS IAM gives you very fine-grained control over any of the resources in AWS. You can specify who can access which services, under which conditions, and it gives you identity. And at first, it appears as if IAM is relatively simple. After all, permission systems have been around in the world for a very long time. But the requirements for IAM are unprecedented. We literally have millions of AWS customers, over thousands of different types of resources, hundreds of AWS services. And they're spread across over all of our regions, our zones, all the way out to the edge. And so the requirements for IAM are mind-boggling. And they come down to two pieces that really needs to work. It needs to be ultra-reliable, it needs to be absolutely secure, and it needs to be incredibly fast. Now, because remember, IAM is part of every API call that you make. And now, so given the importance of IAM, I'd like to pull back the covers a little bit and show you how IAM is designed and how it scales. And I do this because this is truly an example of building a high-scale yet secure distributed system. And core in all of that is that you need to keep simplicity in mind, because otherwise you cannot scale to the scale that IAM needs to meet. Now, so the components in the overall system are, of course, either you use the console or you use the CLI to talk to the IAM control plane, who then talks to sort of IAM services that sit in each of the regions or each of the devices that you're using. Now, IAM means there's two capabilities. There's identity and access management. So authentication, who you are, and authorization is what you are allowed to do. I'll dive into authentication. I think that's sort of one of the more interesting pieces. Now, if you ever set up an AWS account, which I think most of you must have done by now, you know that you get an access key, which is public, and you get a secret key. And the secret key is used to sort of go with every API request that you make to make sure that we understand who is actually truly making this call. So what you do, we ask you to sign every request, send it to AWS, sign it with your secret access key, and this way we know exactly who you are. We do this with a signing process that's called signature version V, SIG-V4 for short. So we sign the request, goes to the AWS service, who then passes it on to the IAM service, who actually checks, who actually does exactly the same signing, see whether the signatures match, and if they match, your request is allowed. If they don't match, your request is denied. Yep. Or not. Now, let's take a look. What we do with signing with is not your secret key. Secret key is only part of that signing process. First, we concatenate the key with AWS 4 to indicate what procedure we're going to be using. Then you do a one-way hash function of that first secret with the date. Then you do the date with the region, and then again a one-way hash function. And in the end, you end up with a key with which you're going to sign your request. And so it's not just the key that we're using to sign. We actually do this for a particular date, for a particular region, and the service you try to access within that region. And so we do exactly the same thing on the other side. Now, to be able to do that, we need to have access to your secret key. Of course, we could be moving your secret key into the IAM service everywhere. But that would be a massive violation of security principles. The secret key needs to stay in the IAM control plane, because there is where we can truly protect you. So what are we going to do? Well, we're actually going to repeat some of the steps of SIG-V4. What the control plane does is actually create a derived key. The derived key actually is just the secret, the date, and the region. And then whenever a request arrives, and we store that in the IAM service. Now, whenever a request arrives, it arrives at what's called the IAM endpoints. And there are literally millions of hosts in the IAM endpoints. And what the team decided is to make use of the capabilities of these millions of hosts to really accelerate the overall checking and signing process. So basically, what the IAM service does is create another derived key. It takes a derived key it got from the control plane and adds the service to it. So this is a key that is uniquely for one user, one service, one region, on one date. And so with this, now suddenly you can cache this at the IAM endpoints and make the checking of the validity of requests really, really fast and really, really reliable. So in essence, if we look at what we've done here, is we built an intelligent hierarchical cache. And there's many interesting aspects to all of that. We could spend a lot of time in, for example, what the caching validation protocol looks like. But here, at very high scale, we've been able to build an ultra-fast access control system that doesn't exist anywhere else. And you can imagine, what all the other components are. Yeah, we really moved cryptography to the edge, making use of the millions of hosts that are the IAM endpoints. And so how big is this really? Why is this really so important? It's because IAM routinely handles 500 million APIs calls a second. Imagine, just for this keynote, 90 minutes or 120 minutes long, I don't know how long we're going to take, how many API calls IAM has handled during that time. And the only way why that is possible is they made the system as simple as possible. Because in that way, you can actually scale to these numbers while meeting the security requirements that a modern IAM system has at scale. Now, the principle there, of course, is that if things become more complex, you shouldn't start with building a complex system. All complex systems that actually work evolved from a simpler system that works. And if you look at sort of simple machines, there are sort of mechanical devices that were used to make the world easier. And so most of them work on the principle of a small effort having a really big effect. Take, for example, an inclined plane. If you had to move this box from here up to there, would take significant effort. However, using the inclined plane, you only have to use a little effort to get a major effect. And there's 6 of these different standard types of simple machines. Now, you can use some of these components to start building more compound machines. If you take a screw, a lever, and a wheel, for example, it's easy to build a wheelbarrow out of that. But still, these compound machines are built out of simpler machines. And that's the reason why they work. And of course, if you want to build more fancier things, not just wheelbarrows, but maybe the nice Mustang that I drove up here, or maybe you want to build something completely different. Maybe you want to build a monster truck or a Formula 1 car. Now, this is only possible because they're built out of primitives. And with all these primitives together, you can actually construct these compound machines. And this is also the principle we've used from day one at AWS. We give you primitives, not frameworks. And why? Because I think if you have to build a framework, then it probably takes a number of 4 or 5 years before you have everything together in the kitchen sink. That means that by the time you deliver it to your customers, it's already 5 years old. And then you have to build with that for something that has to last for the coming 10 years. It doesn't really work like that. What we wanted to do in the cloud is actually give you these small, primitive components so that you could exactly build what you want to build without us telling you how to build it. And so you can see sort of these simple machines as being sort of SQS and S3 and EC2. But you've always asked us for more of these simple machines. More of these components, purpose-built databases, for example. Which means that by now, we have well over 200 of these simpler machines, of these services. And believe me, I know it's sometimes overwhelming, but remember, you have asked for this. It is basically your fault. Now, each and every one of these services has a purpose. And about, I think, sort of 95% of them have been created by your feedback, really helping you build exactly those things that you want to build. Now, some of these services are truly simple, but some of them are actually compound machines themselves. Take, for example, at lake formation. We've seen Adam talk about that, and Swami talked about that. So lake formation under the covers is built out of these other AWS services. Yeah, and whether it is Aurora and DynamoDB or how to get things on premise and Glue and IAM, all these components together make up a lake formation. Or if you're building container applications, yeah, you may want to use AppRunner. So you don't have to worry about Fargate, you don't have to worry about application load balancers and IAM and things like that. Or if you're a web developer and building web and mobile applications, Amplify is probably the tool you want to use. Again, you know, getting in Lambda, getting in S3, setting up Route 53, connecting it back to DynamoDB. Because Amplify really targets a set of developers that in general is not that happy with actually doing backend work. These are front-end developers that really want to build beautiful applications, but often are actually burdened to become full-stack developers because they also have to connect to the backend. Now, so if you think about that, you know, most front-end developers are really good in the visual aspects of building your application. There might be HTML and CSS and JavaScript, but there's all these other things with web apps and mobile apps. That's the frameworks, that's server-side languages, databases, servers, APIs, all these kind of things that front-end developers actually don't really want to deal with. And so the challenges for front-end developers are really, on one hand, lots of these front-end developers, the visual side, is still manual. And then they have to connect the front-end to the back-end, an area where they're actually really not that much interested in. And to help you with all of that, I'm happy to announce today AWS Amplify Studio, which is a completely visual environment to build feature-rich apps in hours and weeks and connect them back to the back-end without you having to do anything. It's really a developer-first approach. It's a truly low-code visual environment where you can literally build web apps and mobile apps in a matter of hours. Yeah, and it's on one hand, it will help current front-end developers move much faster, but also unlock this world for actually new type of developers that may not have that much experience in front-end developing. And to explain AWS Amplify Studio to you in more detail, I would like to welcome Ali Spittel, a senior developer advocate on the Amplify team. Ali.
AWS Amplify is a set of tools that bring the power of AWS to front-end web and mobile developers. With Amplify, you can enable data storage, file storage, authentication, and hosting. And you can use the front-end libraries, hosting, and back-end resource provisioning either a la carte in an existing application or end-to-end in a new one for a seamless experience. When I have an idea for an app, I cannot wait to get it built and shipped. Development speed is so important. So I am so excited to introduce Amplify Studio. It allows me to build my ideas faster, and my designs are pixel perfect without needing to write custom styling code. Amplify Studio makes it easy to work with AWS, no matter your cloud knowledge. You'll find you can quickly build feature-rich, cloud-connected apps that have scale and security built in. To show you what Amplify Studio can do, let's build an app together. I end up at a lot of technical events like this one, and I'm thinking of starting my own. So I'm going to build an app to show off the sessions for my talk. I want to put their sessions on a site so that potential attendees can start getting me feedback about the sessions. I've gotten a couple of the session descriptions back, and I'm waiting to hear from a few others, so I need to make sure that the site is dynamic so that I can keep adding the sessions as they come in. So earlier, I created this data model, and it has 4 fields, as you can see: name, description, speaker name, and speaker image. I can add data fields or even another data model if I need as my application grows. So for example, what room each speaker is going to speak in. I'll change the field type to date time here. You can see how customizable this is. And you can also add relationships between the data as well. You can see that I had 7 sessions already entered in to the data manager provided by Amplify. While I was backstage, I asked Werner if he would like to talk, and he said he wanted to give a talk about the Everywhere Cloud. So let's use this information that I got from Werner to create a new session. I'll plug in that title, description, speaker image, and speaker name, and now you can see that there are 8 sessions for my app. Amplify Studio helps developers and UX designers work better together. In addition to the significant time it takes for developers to make pixel-perfect designs, oftentimes those UX designs aren't implemented properly, which makes UX designers frustrated and makes it so the end user experience isn't as good as it could be. With Studio, developers can import custom UI code from their designers using the popular design and prototyping tool Figma. So in Studio, we'll paste in the link to our Figma file. This will import the UI components that my designer has made into Amplify Studio. You can see that there are all sorts of different ones: marketing, navbar, e-commerce, and my session card. So now I have a data model and I have these UI components. I need to link the two and make it so that my session card shows the information about my speakers and their sessions, not just this hard-coded speaker name. So I'll configure my component, and then I can click to add a new component property. You can see that I can name it myself and then choose the type, which autofills from the models that I've created. Then I can click into the attributes on the UI and click into example for the image, and I'll set the source attribute to my image from my database. Then I'll do the same for speaker name and set that to the speaker name from, again, my data model. I'll do the same for title and description. And now I have my live data on my application on these components. I want to display all my sessions, not just this one, so I'm going to take this session component and create a collection. This will allow me to create a list or grid of all the different sessions that I have. So I can choose from different layouts here, so the grid or the list. I can choose which direction they go in, how many columns, the centering, the margin and padding, all those fun types of things. And I can also choose exactly what data goes in the component. So I can add filters and also sort, for example, by the name of the talk. Now I need to integrate this into my application, and I call this part copy and paste driven development. Studio gives me these code snippets that I can use directly within my own application code to integrate the Studio components into there. I have already created a boilerplate React app with Create React App. So it's a brand new project, but you could also use these components in an existing one if you wanted to. So first we'll run the command amplify pull, and this will generate all the React components from all the Figma components that I had synced into Studio. So you can see all the different components as they're listed out. Then I can use these React components however I want within my code base. So Amplify Studio saves developers from having to write thousands of lines of custom code. It auto-generates human-readable, credible React code. Later, if I need, I would be able to extend this code myself for additional control over my components, or add more data properties if I need as well. So in my React code, I just need 2 lines of code, one to import that session card component, and one to render it on the page. And I can just copy and paste these from Studio. I don't even have to think of them. So here's what my app looks like. All the sessions are displayed. Didn't take a lot of time to build. At any point, you can make changes to your designs in Figma. So I'm not a designer by any means, but let's round these corners out a little bit on the card, and I'll also bump out the font size on the speaker name. I'll go back to Studio and import those changes, and you can see that I can either accept or reject the differences between Figma and Studio. So for example, if I'm not ready yet, or there's a problem with the styling, it's going to save me from accepting too early. Also, I don't need to hand author all of these changes to the design in my own code. So I go back to my development environment, rerun Amplify pull, and all of my component changes and the designer's changes are implemented in the app. Look at those beautiful rounded corners. As an app's use cases expand or an app moves into production, developers may require deeper control over their backend and deployment operations. Amplify's newly launched extensibility features give developers the ability to integrate any AWS service in their application beyond just those offered by the Amplify toolchain. First, you can override the auto-generated Amplify settings using Amplify Override. Then within your code, you can use CDK to get exactly the settings that you need. You can run Amplify Add Custom to add any of the 175 plus AWS services directly into your Amplify application, again using CDK. And then you can also run Amplify Export. And if you need to implement Amplify within your own deployment pipelines, you can export your Amplify app to CDK, and you can run that export process over and over again. It's not an eject where you escape out of the ecosystem. With many other front-end developer-focused cloud solutions, you hit a wall when you keep growing and building. But with Amplify, that does not happen. With Amplify Studio, you can quickly go from a designer's vision to a full-stack AWS connected application that can scale as your business does. Thank you all so much.
Thank you, Harry. Great story, and I'm really looking forward to kind of see what kind of things you guys are going to build with Amplify Studio. Now, how do we build these compound machines? How do all these components get together and get connected? And they're, of course, all driven by APIs. But there is one thing within AWS, is that we sort of value innovation over coordination. Which means that it's not just a service, it's actually a team behind the service that is in contact with their set of customers. And really is thinking about sort of how can we move as fast as possible, addressing exactly the needs of our customers and work backwards from what they need. Now, they're not coordinating with other teams that have other sets of customers and waiting for them to get sort of their interfaces together. We really are focused in each team on their set of customers, working backwards from the customer to create their APIs. If you would be waiting for coordination, we would be in this 5-year waiting game. Because then innovation would get stifled and we would not be able to move as fast as that we're now able to move this fast. Now, it comes with a downside, this lack of coordination. Namely that our APIs are not necessarily coherent and consistent across each other. And why? Is because these teams are focused on their customers, not on coordinating with other teams. And now, quite a few of our partners have asked whether we can't do something about that. Because for them, the fact that, for example, here you have a Lambda API call, one is a get function, and the Kinesis one is a described stream one, all creating different type of resources. You've asked us to create can we do something that sort of supersedes this, that make it easier to start integrating new features and services into our products. And so we delivered the Cloud Control API, which actually gives you a more coherent approach to all the different AWS API calls. It is not replacing the API calls that you have now. Yeah? All of our teams continue to be focused on their customers, working from their customers backwards, and giving them exactly the APIs that they need. And I really, really want to continue to push for that, because I think premature optimization is a killer. Yeah? And really, really starting to think about uniform APIs before you actually understand how your customers are going to use your service is very risky. And to be honest, we've launched sometimes services where customers were using the service then suddenly in every way but the one that we intended it to. And as such, really taking the Cloud Control API as something that is layered over the standard APIs still gives our partners the ability to quickly integrate this into their systems. And companies like Pulumi and HashiCorp are using the Cloud Control API to really quickly integrate new AWS resources into their applications. Now, if we think about 15 years of AWS, we've created a lot of APIs over time. And there's also lots of lessons learned from that. And I just picked 6 of them, but there could be many more. If I think about how to build APIs, these are my 6 short list of things that I first tell engineers that they need to be thinking about. It starts off with that APIs are forever. That means you cannot change or remove an API once you've created it. And why? Because once you put out an API out there, customers are going to build their business on top of it. And you changing that API will basically break their business. That's the last thing you want. And the same is for if you are actually evolving your API, you can never break backwards compatibility. And the way to actually make that easier is to not have your engineers be in charge of what should be in the API. You should make your customers in charge. You should use your customers, work backwards from their use cases, and then come up with the minimal and simplest form of API that you can actually offer them. And this is really important. Imagine you have an advertisement system, and you do 3 or 4 different types of campaigns. Should you have one API call to create a campaign with all sorts of flags and other things to actually modify the API call? Or should you just keep it simple? Just have one create campaign call, and then other API calls to actually modify the resource that you've created with this create campaign call. So make sure that you keep your APIs as simple as possible, because then you create really good building blocks for others to use. And so, again, don't only describe APIs. I think actually 5 is you should be able to look at the API and more or less be able to figure out immediately what it does. And also, not only what it does, you actually really have to document the failure modes. Because it's not only about what your API does, it is how it fails. And whether that is because of the input parameters or maybe security reasons or others, you actually have to make sure the failure modes are well described. And the last one is a tricky one. Avoid leaking implementation details through your API. Because if you do, your customers will rely on it. And they will start to figure out how you've actually implemented this under the covers and will start to actually use that knowledge. It's not a good plan, because that means you can no longer change your implementation, because now your customers are relying on non-functional information. And so with all of this, I hope that you actually take a look at all the documentation and the builder's library documents that we have to dive into best practices around API design. Now, of course, we want to give you tools for wherever you are. And actually where you are right now is that most of you are making use of SDKs to connect to AWS. And you're very comfortable with that, and we've created SDKs for lots of different programming languages. And I'm happy to announce today that we've got 3 more: Swift, Kotlin, and Rust. And I'm especially, of course, Swift and Kotlin are targeting particular platforms, but I'm really happy that we finally have a Rust SDK, because I see an enormous interest in Rust, especially also when it comes to issues as sustainability, making use of the most sustainable programming languages out there. Now, it's not only where you are, it's also where you're going. Yeah, and I do think, as much as I think that the SDKs will be around forever, it's also looking at sort of how would you actually like to build your applications. And I know many of you are programmers and would actually really like to build your whole infrastructure as code. Yeah, no longer a descriptive list that you need to use to set up your infrastructure. You really would like to do this from inside your code. And so that's what the CDK targeted. Yeah, and now you're able to build these constructs using the CDK, and you can share them with others. Yeah, and whether that is with your colleagues or sort of as open source. And the CDK has become very popular. And we've been actually working really hard to improve it. So in CDK v2, we fixed a number of the problems and issues that there were in CDK version 1. Yeah. One mistake we made in v1 was that we basically had a package for each service. And it made it very hard for dependency management. And so, especially for our partners that were building constructs on top of this, they basically needed to load 50 or 100 different libraries before they can actually have all of their dependencies resolved. So now, everything goes into one library. That's the one that you need to use. And we're able to actually then really open up the world for much less complex dependency management. Yeah, we also start making use of what's called semantic versioning, so that you actually know which of the versions of particular objects you're using. And there is something really cool. They call it CDK Watch. I'm not really sure about that name. I call it CDK Hot Swap. Basically, if you write a new Lambda handler or a new ECS task, you do not need to restart your complete infrastructure and restart your CloudFormation templates and things like that. Basically, you can just hot swap your Lambda code in and out without taking your application down. I think that's really absolutely cool. And allows you to continue to have your applications running, even though you're updating and changing code. Now, general available today is also the Construct Hub, which is an environment or a managed site for us to actually give you access and find all the open source and partner cloud development kit libraries out there. To talk a little more about the CDK, and our customers have been using it, I would like to welcome Matt Coulter, the technical architect at Liberty Mutual Insurance, to talk more about that. Matt.
Thank you, Werner. Driven by the conviction that progress happens when people feel secure, Liberty Mutual is a global property and casualty insurer, protecting everything from homes to cars to businesses. We're there to back up our millions of customers when the unexpected happens. Today, every customer interaction is digital, from our applications to our call centers to our websites. And these interactions need to be easy, 24/7, 365 days a year. Our story today is about adaptability, change, new ways of working, and it's about innovation. As a 109-year-old company, we've learned a thing or two about adapting to change. But in the last 10 years, we've seen more change than in the previous 100 combined. To thrive amongst this change, our journey to the cloud became our North Star. This journey began in 2014. We needed to relearn everything about how we delivered software at a time before most serverless AWS services even existed. To succeed, we needed to spark a continuous learning and experimentation culture within our developers. That's why, between 2014 and 2019, we created world-class automated guardrails on our AWS accounts. This meant that our developers could have the confidence to go out and experiment with new capabilities and then bring back the learnings for everybody else. We also instilled the attitude that code is a liability. It's not an asset. What this means is that every single line of code must have demonstrable business value. And this has been core to our evolutionary architecture strategy, rapidly delivering business value in a well-architected way. In 2019, it was time for us to go through another evolution, this time using AWS CDK. But like everything else in life, we needed to start slow before we could gain some speed and then optimize on best practices. It was August of 2019 when we started slow. I created a TypeScript proof of concept, and it was an L3 construct for a fully compliant private API gateway with a custom authorizer Lambda function. This mightn't sound like much, but it reduced over 1,500 lines of CloudFormation down to just 14 lines of CDK. And not only is that impressive because it's less code, but all our teams could share a common construct, which reduces the code liability of the overall company. Plus, it enabled our standard CI/CD practices like unit testing, which was amazing. We then took things to the next level by pairing AWS CDK with AWS SAM for the enhanced local testing. This felt like a game changer. But we were still a long way from using it at scale. To gain speed, we needed to win the hearts and minds of our developers. And that's why, before the end of 2019, we launched a platform called the Software Accelerator. The Accelerator allows any developer to clone a working pattern and have a compliant, production-ready pipeline in seconds. It allows anyone to contribute back their working software, further accelerating our continuous learning flywheel through inner source. My L3 construct was added to the accelerator at launch, along with a stripped-back compliant starter pattern. From here, education was key. We ran the tutorial at cdkworkshop.com several times internally across the globe, and we always finished with every developer creating a working pipeline through our accelerator. This meant that after they left, they could always add the business logic later from any of the open source CDK patterns. Then, I worked with some amazing people to create CDK Day. This was a global virtual conference, and it was so important that Liberty Mutual has had several speakers feeding back into the wider community. A great example of how CDK combined with our accelerator has been core to our continuous learning was at reInvent last year, 2020. AWS Lambda container image support was the big announcement on Tuesday. By the Friday, a working pattern was in our accelerator, and it was being used to solve real business problems by the following Monday. Less than 7 days later. Throughout 2020, our flywheel had accelerated to the point we deployed more than 3,500 serverless patterns. That meant in 2021, optimization became key. We'd spent all this time embracing divergence, but now we needed to converge on best practices. This is where we used the AWS well-architected framework to drive those discussions. We looked at what was common across all of our stacks and introduced core constructs for everyday capabilities like VPC lookups right out of the box. We then experimented with CDK aspects to automatically warn on compliance issues right in the IDE, further reducing developer burden. We now have an ecosystem of well-architected, reusable constructs that allows us to rapidly deliver business value in a well-architected way. The proof? We have teams leaving discovery and framing to deliver working, well-architected products less than 3 days later. We're delivering industry-leading capabilities like our unstructured data ingestion pipeline. It is 96% faster than the manual process and every bit as accurate, all built using well-architected CDK patterns. In fact, a great story is we're so fast now that I had an intern join my team last year, and he was pushing code to production on his first day, and nothing broke. This morning, you heard me talk through how we started slow by learning what CDK could bring to Liberty, how we gained speed through developer education and scaled through inner source, until finally we were taking advantage of everything CDK has to offer, rapidly delivering business value in a well-architected way. We've embraced continuous learning and experimentation to be there and deliver on our promise to our customers in their time of need. This is our mission. A great example of this is we've built a serverless call center that can automatically process a claim after a natural disaster in less than 4 minutes. This allows our customers to piece their lives back together. This is our mission, and this is why we want to use CDK to tell dozens of stories like this. So going forward, we're going to continue to empower and enable our developers to be the best versions of themselves that they can be. We see this as a key differentiator, enabling us to push the boundaries of digital product, reuse, and inner source, whilst enabling our developers to stay in lockstep with our customer needs. So, I challenge all of the builders, dreamers, and doers out there. What was announced this week that you're going to enable tomorrow? Thank you.
Wait here, Matt. Come up here. Matt has done tremendous work for the community and creating really a truly vibrant community around the CDK. And he's gone way beyond just sharing his knowledge and learning. And as such, I would like to give you the Now Go Build Award as a reward for all the efforts that you've done.
Thank you. Thank you so much. Thank you.
Thank you, Matt. So actually, what I haven't told you is that Matt is part of our AWS Heroes program. And so AWS Heroes is a group of worldwide enthusiasts around AWS that are very much invested into sharing their knowledge. And there's about 230 of them around the world right now. And I'm very happy that about 100 are here today in a room up front over there. I'd like to thank every one of those heroes for all the incredible hard work that they're doing to build a community around AWS. Now, if you've been to Peter's keynote yesterday and quite a few of the other leadership sessions as well, you actually have heard us talk about something that is probably on the forefront of everybody's minds today. We've been building technological infrastructures around the world that consume significant energy. And everyone should be aware of actually how much energy they are consuming. And so if you think about, I'm taking this quote from Peter from last year, the greenest energy is the energy you don't use. So how to be more efficient and be more green at the same time. According to a 451 research report, moving on-premises workloads to AWS can lower your carbon footprint by 88%. Remember, we're able to actually get much higher CPU and memory utilization by sort of the management techniques that we use to place your instances and to run your functions for you. And especially those services that are serverless, there we can really make an impact because we can actually engineer there for sustainability and higher efficiencies in ways that are way beyond you would ever be able to do yourself. And I remember in the earlier days when we were talking to enterprise data center management, typical utilization in the data center is 12 to 15%, which basically means that 85% of the energy that you're using is lost, is useless. And so in AWS, we're coming up with this, this model where we would call a shared responsibility model when it comes to sustainability, where AWS is responsible for sustainability of the cloud, meaning that we do good water stewardship, we do lots of innovation in energy management, we're building our own silicon such we can really drive that cost and the efficiency up. Cost down, efficiency up. You, however, as our customers, are responsible for sustainability in the cloud to make sure you pick those technologies that have the most impact for you. And one of them is, for example, to move to serverless. Lambda, our serverless function service, can actually spin up compute to incoming requests. And so as a result, we're able to get far greater utilization, CPU utilization, memory utilization, and therefore energy, because we manage that fleet of servers and can do absolute best placement for that. And as you know, you can also get insights into so how many of these services are running, for how long they've been running, and that's sort of a good proxy for, of course, for cost, but often also a very good proxy for sort of how much energy are you actually really using. And without this, without actually really getting detailed insights, it's very hard for you to really understand exactly sort of what is your carbon footprint. Now, coming soon, and Peter announced this yesterday, is the AWS Carbon Footprint tool, which gives you clear metrics around how much carbon you are using in your applications. And so one really simple thing is, of course, if you provision something, use it. Don't let it sit around doing nothing. And actually, you go back 2012 again, where I would like to say, where I said, don't forget to turn off the lights. And what I mean by that is that with one click of a button, you can scale up. But with that same button, you can also scale down. Scaling is not only about scaling up. Scaling down is equally important. And every resource that you're not using is the greenest resource that you can think of. Now, I've also been thinking about something else, and it doesn't really fit yet in this shared responsibility model. There's also something you can start thinking about, is what is actually a good latency towards my customers? Imagine the average latency or the 99.9% latency of your web pages would not be 1.2, but 1.5 seconds. How much more energy would you save there? If you look at the current Twitter stream, probably, was it 60 or 70% of these tweets have rich imagery associated with it. What if your images are not at high resolution? What if you use less imagery? How much less energy are you using? And so thinking about your customers and how you present your products to your customers, and what can you do at the design level to think about, if I design it this way, it will cost more energy. So thinking about the architectures, not only about how am I using AWS, am I using the most sustainable technology possible, but am I building the most sustainable application? So start thinking about that. Keep that in your mind. Now, to think about sort of sustainability, I always talked about the well-architected framework. That had basically 5 different pillars: security, reliability, cost efficiency, performance, and operational excellence. And I'm happy to announce today that there's a new pillar, which is the AWS well-architected sustainability pillar. That will give you advice. That will give you advice about best practices that we've seen. And we'll continue to update the sustainability pillar as we get more and better insight into how to give you advice to build sustainable applications. Now, sharing knowledge like this has always been important. And so we can collectively work together and improve software development. And one particular area that I think we've been lacking is actually helping to answer your questions in an authoritative way. And so the past years inside AWS, we had a tool that's called AWS Answers. And basically where our support people or our engineers were posting questions from their customers that they couldn't find answers for. And then other engineers will be answering them. Basically, you're getting authoritative answers to questions that really matter for our customers. And so I'm happy to announce today that we're launching AWS Repost, which is a question and answer site for you, where you can get authoritative answers about any questions that you have about AWS and the architectures that you want to build. And I wouldn't forget, of course, remember 2 years ago, I launched the Builders Library. And I want you to continue to check this out. This is not just the Builders Library with experiences from our distinguished engineers, but it's also from over all of Amazon. This is basically 25 years of experience of building high-scale distributed systems. And there's 2 articles I want to call out actually there. One by Malcolm Venterby, which is about idempotent API, how to build idempotent APIs. And a very interesting one by Colin McCarthy about sort of doing constant work and how that actually helps you to build scalable systems. I urge you to check out these articles because they're absolutely really cool and full of advice that you can apply immediately to building your own systems. Now, the cloud continues to change development. And it was our goal, because we want to work together with you to really build those tools that you need to have, those simple machines and compound machines that you need to build your applications of the future, not those applications from 5 years ago. And as such, it's not just the cloud changes development, you change the way that we work. You change the way that the cloud works. We have this very tight feedback loop with our customers that continuously change how we are delivering new features and new services. Now, I'd like to bring some advice back from what I gave a number of years. It was a sort of a joke that I made, but I hope you take this serious. So there's a very famous quote from Edgar Dijkstra, who's a Dutch computer scientist at the University of Austin, decades and decades ago, really into formal verification and things like that. And so his quote was really that if you do something quick and dirty, you suddenly visualize that I'm looking over your shoulder and think, Dijkstra wouldn't have liked that. And that would be enough immortality for me. Now, I've modified that quote. So if 10 years from now, you're putting something piecemeal together instead of just using AWS, I hope that you suddenly visualize that I'm looking over your shoulder and think like, Werner wouldn't have liked that. Yeah? And that would be enough immortality for me. Now, what we've done here, why have we created all these services, all these features, is really, and I think the words of the famous philosopher Daft Punk really are applicable here. We work it harder, we make it better, we do it faster, and it makes us all stronger. And really, this has driven this huge collection, the biggest and broadest set of array of cloud services that you can imagine. And you can build infinite different ways in many different types of systems with all these components. Now, what if you would want to build something completely new, something that has never been built before, and that you can only build because you build it in AWS? So, how would you build something really completely new? Let's watch this.
The stories you've heard, they don't tell the whole truth. The island is indeed a place of legend. There is power riches as well. But many who've sought to claim them have simply vanished without a trace. Your ship is stocked and your crew assembled. Chart your course and your fate. We can pretend no longer. This corruption must be stopped. I will say a prayer for the souls of your crew.
So New World is a game designed by Amazon Games. And it's a massively online multiplayer game where players from all over the world can connect together and play together. What you can do is you can create a custom character, enter the world, and over time your players progress. You carry more items and experience. And it's not a session-based game in that sense, that once you log out, you lose everything that you had. It's something where you can really grow over time. And so this player navigates the world and can sort of explore all the different areas. And it's really expansive. And what you normally had with these games is once you move from one piece of an island or one piece of the world to another, you get these loading screens and things like that. That's not here. It is completely immersive. And the things you can do, of course, is like usually in gaming. You can do combats, you can fight, you can craft things, you can trade, and you can go on missions with other players. And players are free to explore this world in any way that they want. Now, when you look at New World, you may see a game. I, however, see a massively distributed system. And so let's take a look into how this actually is constructed. Now, first of all, if you think about the old world was game servers. And game servers were actually really servers. You would connect to it, the game would run into that, and it would be a single physical server for you to use. So in the old world, if things needed to scale up, you need to scale up, basically by bigger hardware. In the new world, it's all about scale out. So architecturally, how does this look like? It starts with what's called remote entry points, or RAPs. There's 4 of them in each world, and basically they're a proprietary application router. Clients connect to that, and there's where both security and resilience is handled. And RAPs are also the only public-facing access points to the whole game. Then in that world, behind it, sit the computational processing unit. We call them hubs. You get 7 of those. And each hub owns a compute for a portion of the world that you're operating in. And the third piece of this is a warm instance pool that is shared on a per AZ basis, where you can actually go on specific missions. You can go like fighting, or you can go on expeditions, and actually then you use instances from those pools for the single gameplay there. Now, Ethereum, as the world is called, is actually built out of 14 smaller regions. And overlaid on top of that are a series of grids. And so in a single world, you can have 2,500 players. There will be around 7,000 different AI entities and literally hundreds of thousands of objects for you to work with. Now, if you look at sort of the hubs, how they're processing this, we've actually taken the world and put a grid over it. And each of the hub servers, hub instances, are picking up 2 pieces of this grid. These 2 pieces are not consecutive. So if you move, for example, from block 2 to block 3, you're basically handed off to another hub instance. And these are not consecutive, so you won't stay at the same hub. This really spreads the load out very nicely over all of the compute servers that we have. So each of these grids represent a physical simulation volume, and you can continuously move objects and AI entities around the world, moving from hub server to hub server. Now, when we launched New World, we started off with roughly 185 of these different worlds, spread out over multiple regions across the world. Within 10 days, there were 500 worlds. And believe me, the only way you were able to actually get this scale is because of the architecture, how we've made this. Now, it's important that there's these many worlds, yeah? And so something that is really radically different, what you just saw in the gameplay there, in a traditional game, probably 5 times a minute, the user state and actions are being processed. In New World, we're able to do this 30 times a second. And so everything is simulated, redrawn, analyzed, and events are processed 30 times a second for all the world's entities. And this kind of game simulation requires a lot of CPU and is really enabled by the use of multiple EC2 instances powering this world. It leads to very immersive gameplay and a much better end-user experience. Now, of course, there's a lot of game state, but in essence, these game servers, the ones in the hub, are stateless. They have ephemeral state and sort of in-memory state, but they can always be restarted. And even if all the hub instances fail, we're able to bring them up quickly back online and restore the game state as it is. And why is that? It's because we're routing everything to DynamoDB. And it's about 800,000 writes every 30 seconds to sort of store the game state in DynamoDB. Important is, of course, in such a massive distributed system, is that you have good insight into what's happening with all the different components. And remember, 500 worlds times each of that set of servers, and you need to actually be able to operate it. Now, as I talked about last year in my keynote, observability is extremely important. And to be able to actually really get the observability, meaning on the outside, you can infer from what you're seeing what the internal state of the system is, you need to log everything. And sort of in a distributed system, it's important that you log this so that you can get the insight into exactly what each and every one of those components are doing. In New World, they use Kinesis to log events. And sort of about 23 million events every minute are being pushed through Kinesis into S3, and where it's then processed using Athena. And so this enormous data flow is used by every aspect of the team. Now, data analysts can discover everything from which wolf in the forest have been fought most, or which paths are most traveled, or game designers can figure out how players are enjoying their game and can modify the game in real time based on this data. And also operationally, they are aware, of course, of what each is doing, what the behavior is, anticipate service issues, and deal with them really quickly. So with that, there's also the side, of course, of all of this next to the instant gameplay is all the things that are around it, and whether that is the operational side or, for example, how trading and buying is being done. And so all of that is not running on any EC2. It is using Lambda for all of those. They power their control plane with it, but they also power all the non-core gameplay activities by using Lambda. Now, one thing that I mentioned earlier is that there's the ability to actually also do session-based modes. Basically, you can invite 5 of your friends, and you step through a portal, and you go into a dungeon, and you're going to slay some dragons there. But under the covers, you're actually playing on one of these EC2 instances that comes from the shared instance pool. And this allows us to free up the traditional processing of gameplay, and the session modes are done on a separate pool of instances. And once you are actually finished with your quest and return to the world out of the dungeon, that EC2 instance is returned to the shared instance pool. So you end up with a quite interesting large-scale architecture that is really built with a service mindset in mind. And serverless indeed plays a very important role in that. If you look at sort of how what the numbers are there, there's well over 150 million Lambda invocation each minute. There's 200 million calls for the API gateway. Elastic Cache easily gets through 275 hits a minute. All of these things would never have been able to achieve if you would have to do this in on-premise with your own hardware. Now, this truly is an MMORPG game born in the cloud, and it would only have been possible to actually run this in the cloud. It would never have been able to build this sort of totally immersive experience using bare metal. Now, if you think about this, now suddenly with AWS, you can build systems the way you always wanted to. There's nobody that tells you what you cannot do. There are no gatekeepers. You can build the way you always wanted to build your applications. And it means you end up with applications that are fault-tolerant, secure, scalable, cost-effective, and sustainable. And that's really important. I call this, going back these 10 years, 21st century architectures. And if I look at and I urge you actually to look back at that first presentation I gave, because there's lots of really solid advice from day one. And if I look at the advice I gave you in those days, they're all very solid and have allowed many of our customers to scale to unprecedented scale and maintain ultra reliability and security over time. So if I look back at some of those, protecting your customers will be forever, should be forever, your #1 priority. It is definitely ours. It will be forever our #1 investment area to protect you. And actually, if it's coming, when we're talking about protection, you should build security from the ground up. And this is a conversation I often have with younger businesses who are so gung-ho on building a new product that they want to build. I actually urge them on day one to start thinking about how to protect my customers, how to make sure I am as secure as possible, what are the tools and techniques that AWS gives me so that I can protect my business as well as my customers. And the same goes for the other non-functional requirement. Instrument everything, all the time. And why? It's because these two things, security and operations, are something that you will probably have to do for the rest of your life, of the lifetime of the system that you're building. The time you operate and protect the service greatly outreaches the time that you actually spend on building it. So every investment you make in security, as well as in operations, will pay off forever. Now, with this advice, I will leave you. I'll hope you see you guys tonight at the party with Zed. And with that, thank you, and now go build. Ha!